All right, this is lesson 5.7, Scale Models and Indirect Notes. We're on pages 12 and through 14 in your notes packet. So we're going to start off with 5.7 scale models. Scale models represent an object either larger or smaller than real life. So for the first example, on a blueprint, the basement is 4 inches long by 3 inches wide. The scale is half an inch is equal to 8 feet. Find the missing dimensions. We're going to start off with the length, which was 4 inches. Starting with the scale, that's going to create the first side of your proportion. So you pretty much just fill it in. Inches over feet are your labels, so you'll keep those labels on the right-hand side. The length in our problem is 4 inches. Inches is on the top, so I'll put the 4 there with an X on the bottom. Multiplying using the cross product, I'm going to get 1/2 X equals 32. I'm going to multiply by the reciprocal using that inverse property. Eliminates the numbers with the X here. So we get X is equal to 64. And my label that goes along with X is feet. I can see that in my proportion. For the width, again, I'm going to start with the scale. So we have half an inch over 8 feet, inches over feet, inches over feet. And we have 3 inches wide. So we're going to put a 3 up here and an X down here in our bottom. Again, the cross products give me 1/2 X is equal to 24. So I'm going to multiply by 2 over 1. And I get X is equal to 48. And again, my label here is feet. For example number 2, a carpenter wants to build a desk like the 10.5-inch one his daughter has for her dolls. The scale he is using is 3.5 inches to 1 foot. This scale is going to start the left side of our proportions. We're going to do 3.5 inches over 1 foot. Inches over feet, inches over feet. We have to keep them equal because of the proportion. The desk he has is 10.5 inches, so inches is on the top, 10.5 will go up there, X will go on the bottom. So we're figuring out the height of the life-size desk. 3.5X is equal to 10.5. I'm going to divide by 3.5 on both sides. We're going to get X equals 3. The label for this is feet, and we can also say in real life, because this is the life-size desk. For number 3, we're going to be talking about a tennis court. It's 36 feet wide. So if I look at this, length typically goes across. Width is typically going to go down the side. A drawing of the court is 2.25 inches long and 1 inch wide. So what scale is being used? We want to compare the sides that are corresponding in the same spot. So we would say that on the drawing, we have 1 inch is representative of 36 feet in real life. So we can find the length of the court in real life. We'll say 1 inch is equal to 36 feet using our scale on that side, inches over feet. For the length, we know that in the drawing, it's 2.25 inches. In real life, that's X feet. X times 1 is X, and 36 times 2.25 is going to give us 81. And X's label is feet, so we're going to go ahead and label this with feet then. For number 4, model train scale O is 1 to 48. The village below was created to look like a real town. So the 1 represents the model, and the 48 represents the real one. The real town's post office is 12 feet tall. How tall is the model in inches? So we're going to do 1 is 1 foot in the model, represents 48 feet in real life. So for us, 1 foot in the model, feet in real life. So this is my model on the top and real on the bottom. The real post office is 12. So 12 feet is going to go on the bottom, and X is our 1 in the model. So we're going to go ahead and figure out the height in the model. 12 times 1 is 12. 48X, divide through by 48. 12 divided by 48 is 0.25 equals X. And this is feet. But you'll notice that the question said in inches. So 0.25 of a foot, there's 12 inches in a foot. So 1/4 or 0.25 of 12 is going to give me 3 inches tall for that. For number 5, on the map, the distance from Seattle to New York is 8 inches. How far is the distance in miles? So we're looking for a scale here, which I do notice down here on the bottom of the map. So my scale sets up the left side of my proportion. Inches over miles. I'm going to keep that the same over here. And notice that I have 8 inches on my map. So that's going to go on the top, X on the bottom. So we're going to have x equals 557 times 8, which is 4,456. X's label is miles, so we're going to go ahead and put that label on. For the next part on page 14, we're talking about similarity and indirect measurement. So indirect measurement basically means that you have an object that you can't actually take a tape measure, a ruler, or anything like that to specifically. So you use similar figures to measure an object. And a lot of times what we're going to see here is we are actually going to use shadows. And this was important because back in ancient Egypt and stuff, and back in the early, it was like around the 1500s or so, mathematicians were actually able to calculate the heights of the pyramids by doing this. They compared their heights and their shadow at the same time as comparing the shadow of the pyramids to figure out and calculate the height of it. So we're going to see this here. We have a school that's 40 feet high. That's the height of it. Casts a 160-foot shadow. The shadow is going to go down on the bottom here. A nearby cell phone tower casts a 210-foot shadow. So that's going to go across the bottom. Find the height of the tower. So we're looking for x feet. In similar figures, you'll remember that we circled and we boxed, and then we wrote proportions, and we said these ones will go on the top, these ones will go on the bottom, and we're going to follow that same idea here. So I'm going to do 40 feet over x feet is equal to 160 feet over 210 feet. So 40 times 210 is going to be 8,400 equals 160x. I'm going to divide through by 160. And that gives me 52.5 equals x. 52.5x gets feet. And we can also put the word tall for this one because that's the height of the tower. In example number 2, we have a fire tower that casts a shadow 30 feet long. Nearby tree casts a shadow that's 8 feet long. How tall is the fire tower if the tree is 20 feet tall? So this is 20 feet, and we're trying to figure out how tall is this. So the 20 is in the same spot as the x. The 8 is in the same spot as the 30. So I'm going to go ahead and just do 20 feet over x feet. And I'm going to do 8 feet then, which is the tree's shadow, over 30 feet, which is the tower's shadow. It's going to give me 600 equals 8x. I'm going to go ahead and divide through by 8. That's going to give me 75 equals x. That's going to be feet tall then. And that's it then for your lesson for using similar figures to help us with scales and also with indirect measurement.